And yesterday we had the emergency training brief, so there will also be changes compared to the Soyuz when all the vehicles were, let me say, in the back part of the station or in the Russian side of the station. Now we will have Western USOS crew flying to the front side of the station and Russian crew to the back side. So in an emergency we need to go separate ways. So that changes a little bit what you do when there's fire, when there is loss of pressure and toxic atmosphere. So,
and those are the times when, speaking about what is nice to know, what you need to know, those are the times when you need to not even think about what you're doing. It needs to be automatic, because it's going to happen in the middle of the night, it's going to happen at the worst possible moment. It's Murphy's Law, right? Yeah. So you need something that is hard, that resists every circumstance. And that's why I try to break it down to very, very simple principles that you will always remember and always apply. And those actions at that point in time, they don't need to be the most optimal actions. It doesn't matter, because you don't have time. You're trying to save your life, you're trying to save the vehicle. They need to go in the right direction every single time. And that's why of all the trainings that we're doing, there's a lot of things that is in cooperation with the ground, and you don't need to know much, because those guys are going to be there to help you out, to answer your question. Then there's some more systems-oriented training. You need to know quite a bit, because you're going to have your hands into the systems, but still you can get some help. And then there's really the emergency, degraded situations training, in which there's a good chance it's going to be just you, and you're going to have to take the right action. So no pressure, Matthias.
I had it last week in a simulation. All the pressure.
There you go.
But did it happen to you in space that you had an emergency, even if it was a false emergency?
We had a false fire alarms. So the smoke detectors on stations, sometimes they react to dust, because they measure the conductivity in the air to detect if there's smoke or not. So sometimes they trigger falsely. And we had this twice. And the first time, my first reaction was, oh no. I don't want to be that guy when the station burns down while I'm up there, and that's actually not the reaction to have. The first reaction I should have had was, okay, what's my emergency response? What are my immediate actions, etc., etc. So actually, I took it as a learning experience, and then the second time it happened, we were sharp as a knife. But the first time, your first thought is always, not me, not now. Why is it happening to me? And you lose a couple seconds, but you put yourself on the safe side, and then it turns out to be a false fire detection. Happens. There's been a false ammonia alarm, toxic atmosphere, and there's been a depress, which was a real depress, slow, but real. So we don't just train for training. You train also for the real life.
For the real case. Talking about, we don't need to take care of everything because the ground is there. At the end of this hall is the future. There is the Deep Space Gateway model. There are also like rovers for on the moon, and going to the moon. And I think we will have less the chance to rely on ground support. For the moon we still have, but once we go to Mars with all the 40 minutes, up to 40 minutes time delay, like in both ways, like out and back, 20 minutes each, I think we need to become way more independent. And seeing what ground control does for us on the ISS, I think that will be a heavy burden for the astronauts of the future.
Yeah, I agree, but hopefully the systems are going to be more streamlined and more simple. And the ISS to me is a marvel of engineering. It's one of the most complex pieces of engineering that was ever made in the history. But the flip side to this is there's a lot for just one person or 6 person or 10 persons to know. And that's why we have experts in every single system, every single box, every single device that we have on the space station. And that's why we don't have to know everything. And we couldn't, nobody can know everything. But you can't go to Mars with something as complex of the ISS. So it'll be smaller, more streamlined, more automated, and hopefully there's less to know.